Hi everyone, welcome in this video. We will be talking about low level design or LLD. You probably have heard about high level design, you would have seen a lot of high level design interview videos, but the topic of low level design is very less covered here on YouTube. So, what I thought was to start making videos and see where it goes. So, low level design. Starting with the standard definition, breaking down or designing the real logic into extensible, testable, and readable code. What I mean by all of this? Extensible means that your code should be able to extend for a new feature. Testable. So, testable means your code should be highly testable, or you should be able to test your code very easily. Testing can be either unit testing or integration testing, and so on. Testability also comes into place when you're doing, let's say, test driven development, which I might go about in this course. Third is readable code. Readable code is very important because the code that is written by you might be read by some other colleague of yours, or maybe you read the code that you wrote in the future. So it should be highly readable, you should be able to understand it. Starting with the foundation of low level design is solid principles. So for solid principles, they are a set of 5 principles as the name suggests: SOLIND. In this video, I'll cover all of these with example, with what is the problem in that example and how we can use these solid principles to make that particular piece of code better. Starting with S. So S stands for single responsibility principle, or also known as SRP. So what SRP says is a class should only have one responsibility. This is very important. Or a class should have only one reason to change. So let's say you have a task manager class. So what the task manager class currently do is it manages tasks, it sends out notification to the users, or maybe notification to some other clients, logs notification events. So this is not doing a single task, this is doing multiple tasks, as we can see here. So you would say, what is the problem here? So let's say tomorrow we get a feature that we want to change the logging logic. We do not want to write the logs inside the file, we want to write the logs directly to some other service, or maybe we change the notification logic. So currently we have some notification service, external notification service that we are using here, and now we want to move to an internal notification service. You would require to change the task manager class. Ideally your task manager class shouldn't have been changed here if the only responsibility it had was only managing tasks. So this is a badly designed class. How we can fix it? What is the solution? Break the class into 3 different components. So it's quite simple. You have a task service that manages tasks, you have a notification service that looks after notification, and you have a logging service that does all the logging part. So O in solid stands for open close principle, or also known as OCP. A class should be open for extension but closed for modification. What do I mean by that? Let's take an example and you would definitely understand it. Payment service. So we have a payment service class here. The payment service has a method known as pay, and it takes the type of payment method you are choosing. Let's say you choose UPI or you choose a card payment. There will be some code executing over here, right? We do not want to look into that code. So this is the payment service. Now you would say it is completely fine, we have an if and an else. What is the problem here? So the problem is on adding a new type, you are violating this principle. So the OCP open close principle you are violating, because adding a new payment type will change the code where there is, like, let's say logic or some sort of a if else here in this particular payment service. Ideally you wouldn't want to change the payment services when you are adding any new payment type. You would want to keep it intact, because let's say it is tested, you wrote unit tests, you wrote integration tests, you did a good QA on that, and you are perfectly sure that your payment service is working well. You do not want to touch it for adding any new payment method type. So that's why this class is a problematic class. The design is not up to the mark. So what is the solution? So the solution is quite simple. You create a payment method interface and extend from it. So from the payment method, you would have a card payment, you would have a UPI payment, and then you would have a wallet payment. Don't worry, I will provide working Java examples in the description below. You can check that out. Why? So why do we want to do this? Why do we want to follow OCP? Right? So less bugs by like not touching the piece of code, not modifying the piece of code that is already tested. You can reduce the number of bugs in your code. Your code becomes quite modular. If you want to touch UPI service, you have no uh, reason to touch the wallet payment or the card payment service. Next is L. So L stands for Liskov substitution principle, also known as LSP. Subtypes must be suitable for their base types. So this definition, I would say, is very vague, and you wouldn't understand a lot from this definition. The example definitely covers it, and you will have an idea what I'm talking about here. So let's say we have a rectangle class. It has two methods, set width and set height. We have a square class which extends the rectangle class, which also have to now override the set width and set height, right? So this is the code that we are using. So this is the use of above code, right? So we are having a resize method. We take a rectangle as an input, we do set width, we do set height, and then we print the area. So rectangle can be rectangle, or if you inherited a square from a rectangle, it can also be a square. So for rectangle, you will get the correct answer, which is 5 into 10, that is 50. But for a square, you will get 100. And the reason for that is you did set width 5. So first it will set height and width as 5. Then it will set a height of 10. But in the square, you know that your height and width are exactly similar. That's why it is incorrect here. So how would you solve this? So it is very simple to solve it. You shouldn't have a relation between a square and rectangle because they do not relate in a real world entity as well. A square would have different properties, a rectangle would have different properties. So you can create two separate interfaces that represent your rectangle shape or a square shape. So next is I. I stands for interface segregation principle. What it means is client should not be forced to depend on interfaces that they do not use. What I meant by that, let's take the example. Let's say we have a media player here that have two functions, play video and play audio. There is another class that implements the video player, which is the audio player class. The audio player now would have to implement both of these functions, play video and play audio. But do you think there would be any piece of code here in play video? It would either throw an exception, that not implemented exception, or there wouldn't be any code, it would be an empty function. And in the play audio, there would be some logic here. So why are we implementing this function when we do not even need it? So this is what the interface segregation principle says. Bad design, which you can see clearly, as we would either make play video in the above example as empty or throw an exception, right? And as a client, you wouldn't know that when I take an interface, create an object of a class, and then I call a method, would I get an exception? Would it be a empty function call, or would it actually perform some sort of an, what would I say, action, right? Solution quite simple. What you have to do is to create two separate interfaces. You can create an audio player interface and a video player interface and have a play method in both of them. So any kind of a player that only plays an audio, you would implement from this, and for video player you would implement from this. And the last but not the least is dependency inversion principle. I believe that this is the most important principle out of all of them. So dependency inversion principle states that high level modules should not depend on low level modules. Both should depend on some sort of an abstraction like an interface in Java. What do I mean by that? Let's take an example. There is a class known as user service. It has a file logger. Here we are creating a new object of file logger. Then we have a create user method which says logger.log something, and it is also having some other piece of code which we are not interested in. Right. So this code might look correct to you. You would say, what is the issue in this code? It works perfectly fine. If you want to understand the problem, the main thing is testability of this code. So if you want to test the class, test the logger, it would be difficult to do. The only way in Java you can do is through reflection, which is considered as an anti-pattern unless or until you know you are doing what you are doing, right? You should stay away from reflection if you do not know, and in this case you shouldn't use reflection here for testing this piece of code, right? Also, changing loggers to something like database logger would require to change the user service, which shouldn't have been required. So we do not want to change the existing written code. The entire solid principle states moves in one direction, I think, is that do not modify the existing pre-written code, try to extend it. So as much as you do not change the pre-written code, the better you are, the less bugs you will get, the better testability you will have of your code. So for this example, what you would do for a solution is you would create an interface logger. So as I said above, that depend on abstraction like interfaces. So interface logger, which has a log method, takes a string message. This can have two implementations, file logger and database logger. And then is the user service. We are not creating the logger ourselves, we are passing it in the constructor. So this is also known as dependency injection. You are not creating the dependency that you want, you are injecting the dependency from someone else. So this code become highly testable. You can create a test logger by extending from this interface, pass it down here, and then you can assert any kind of a method. And yeah, so you do this dot logger is logger, and when you do create a user, just say logger dot log user created. So this was all about in this particular video. In the next set of videos, we will be talking about design patterns, and we will look at some real world example. So if you like this series and you want me to continue this series, do hit the like button and let me know in the comment section what you think about.